Hey students, Mr. Helpern here. This is the third video. In this video we're going to talk about limiting reactants or limiting reagents, they're also called, and also how to calculate the excess reactant, what's left over. So this is an example here. So if you have 4.95 grams of ethylene and it's being combusted with 3.25 grams of oxygen, what's the limiting reactant or reagent? Okay, so the first thing is just to write out the formula here. So our fuel is going to be C2H4. We know that it combusts with oxygen gas, and it makes, by the way, CO2 plus H2O. So we want to balance this first. So this is not balanced yet. So we're going to say that there are two here because there are two carbons, and there are four hydrogens here, so I'm going to put there's two there. And then finally I have six oxygens, so that's three carbons there. Okay. All right, so now this is balanced. Now we're going to figure out what the limiting reactant is. So to do this, we have a few steps that we do. The first thing is we are given two different reactants here for both of these. So we're not sure which one is the limiting reactant. So what we're going to do is we're going to solve for how much product it can make, right? And so what we're going to do is try to solve for how much CO2 can actually be produced, right? Now, to be honest, it doesn't really matter if we're solving for CO2 or if we're solving for H2O. We'll get the same answer for which is the limiting reactant. But I do notice that in the second question it asks how many grams of CO2 are being formed, so I'm kind of doing that one. All right. So let's try this. We're going to start with the ethylene because that's the first one I see there. So 4.95 grams. We're going to figure out how many grams of CO2 that would produce. Okay, so C2H4. So we're going to convert that using molar mass. So carbon is 12 times 2 is 24 plus 4 is 28 grams per C2H4 for every 1 mole of C2H4. Now, moles of given, which would be the moles of C2H4, which is just 1 in this case, 1 mole in the chemical reaction. And what we want to find is how many moles, ultimately, how many grams of CO2. Now, CO2 has a 2 coefficient in front, so that's 2 moles of CO2. And finally, to figure out how many grams per mole of CO2, and that would be carbon being 12, oxygen being 16, there are 2 of them, total that would be 44 grams of CO2. I want to double check all my units. They look good, they're canceling out. I'm left with grams, so I'm going to solve for this. So 4.95 divided by 28 times 2 times 44. $15.6. Okay, now this doesn't give me any information yet, right? Because I don't know how much product CO2 are being produced if I have 3.25 grams of oxygen either. So I need to first do that. So these problems, as you can see here, are not too challenging in terms of like it being different than the other problems we've done. It just is like a bit more work, right? So we're going to do molar mass again. So 32 grams of O2 for every 1 mole. The ratio would be 3 moles, and for every 2 moles of CO2. And then similarly, we have 44 grams of CO2 for every 1 mole of CO2. And finally, I do my math. 3.25 divided by 32 times 2 divided by 1 by 3 times 44. And what is it again? Times 2 divided by 3. Yep. Times 44 equals 2.98. Call it, yeah. All right, so clearly in this problem, we see that if we have this amount of oxygen, right, that we will make a lot less CO2. So oxygen gas is going to be our limiting reactant, okay? What is our limiting reactant? It's oxygen gas. How many grams can be formed, right? So if I had this amount, 4.95 grams of C2H4 and 3.25 grams of oxygen gas, the maximum amount I could use, or make, sorry, would be 2.98 grams of CO2, right? After that, all of the oxygen that we had will be done. That's like there's no more left. And so you got a bunch of C2H4 just kind of sitting around because fuel can't burn without oxygen, okay? You can't combust a fuel without oxygen. So once you hit 2.98 grams of CO2, that's the exact amount you can make, maximum you can make, with 3.25 grams of oxygen gas. Okay? So the last question is, how much excess reactant is left? How much do we have left of the excess? Well, what's in excess? The oxygen or the C2H? It's the C2H4, right? Because we said that we were burning, the limiting reactant was O2. So how do we figure that out? So the first thing we need to do is identify what is the limiting reactant, right? So what is the limiting reactant? The limiting reactant is the oxygen. So in this case, it's the O2. The second step that you do is we use the original amount of limiting reactant which is 3.25 grams of O2 to calculate my goodness, Mr. Halpern, the amount of excess product needed. So what this step means is you're going to use the exact same number, 3.25 oxygen, but instead of trying to solve for a product of CO2, we're going to try to solve and see if I have that much oxygen, how much C2H4 will I need for the oxygen to completely be used up. And the last step, once we figure out that number, the amount of the excess product that was needed, we're gonna take the difference. Okay, we're going to take the difference between what we just got as needed for the amount of limiting reactant versus what we actually have, which is 4.95, and see what the difference is. So let's show you an example. So how much is left? Well, first step, identify the limiting reactant. That's oxygen. So we're going to use that original amount, 3.25 grams of O2. And what we're going to do is we're going to figure out the amount of C2H4. So we're really just living on this side of the reaction to figure out the excess. All right? So first we're going to convert this again to the amount of moles. So 32 grams of O2 for every 1 mole of O2. Now what is given to me is the moles of O2 for O2. And what I want to get, what's unknown, is C2H4. So what is my relationship between those two? So for every 3 O2s, I have 1 C2H4. And last but not least, I'm going to figure out my grams. So my grams are here. I have 1 mole C2H4, and in 1 mole of C2H4 I have 12 times 2 plus 4, 28 grams C2H4. And what I get 3.25 divided by 32 equals, and then I go divided by 3 times 28, and I get 0.947. Call it 0.95. What does that mean? That means that if I use up 3.25 grams of O2, if I use it up completely, I will need 0.95 grams of C2H4. Once I use up that 3.25 and that 0.95, that's it. There's no more oxygen left to react. So what that means is that anything more than 0.95 grams of C2H4 is excess. So in this case, we have 4.95. So what do we say? We take the difference. 4.95 minus 0.95 equals 4 grams of C2H4 in excess. That also means just like leftover, just kind of sitting there. And that's it. Okay? We need to go back and review from this video the different steps that we use to get to the limiting reactant, identifying it, and then figuring out how much we can make of a product ultimately, and then the excess reactant, how much left. Hope that was helpful.